Okay, so just a little update on what we're doing here. Today is Monday. We're basically going to work today on those 2.6 equations, the 10 of them that I gave you on Friday. Hopefully you got maybe 2, 3, 4, maybe you got all of them done. And then we're also going to work on, if you want, your 2.5 Excel spreadsheet calculator. Okay? And if you're done with both of those things and you're confident in all of it, then you're not going to have much to do today, except maybe help your neighbor or ask me some questions on something that you want to work on. So that's the plan for today. On Wednesday, we're going to talk about 2.7. And on Friday, you guys are going to take your Chapter 2 test. So let me start with these problems that I gave you. And I want to talk just briefly about each one, not solve each one yet. I want to give you some time to work on it. I got to turn this on for the online students here. Let's see. Capture device. Oops. But you got to do this first. Sorry, bear with me here. Okay. Let's just talk strategies really quick here. We kind of did this on Friday. If you could sum up a strategy in one word for this guy, what would we do? Go ahead, Luke. We'd factor it. Yeah, we want to factor it. And notice that it's to the 4th power. Therefore, we know when we're all said and done, we're going to have 4 answers. So your goal is to try to figure out how can I get this something times something times something times something equal to 0. So one way to start would be, let's just set everything equal to 0. So I would go like that. Can I turn that into 4 different parentheses? Try to factor it out. What do you think for number 2? How many answers am I going to get for number 2? 3. How am I going to get there? I'm going to factor it again. So I could go 2x cubed plus 3x squared, move this stuff over, minus 8x minus 12 equals 0. How many parentheses am I going to end up with when I'm all said and done? 3. So if I can get it into something times something times something equals 0, then I can set each one equal to 0, and I would be able to pull that off, right? So this one's going to have 4 parentheses when you're done factoring. This one's going to have 3. And then I'll walk around and help you out if you're struggling factoring on that, and Oren is here to help as well. How about number 3 and 4? What's my strategy going to be?
Square them.
Yeah, we need to square both sides of the equation to get rid of a square root. And we talked briefly about this one on Friday. What I'm not going to do is square it the way it is, because that's going to make a miserable, ugly thing. But if I were to move this 3 over to the other side, subtract it, now if I squared both sides, notice my square root and my square are going to go away. So common algebra mistake, a lot of students will screw this up. X minus 3 squared. Lots and lots of students think that this is x squared minus 9, and they are wrong. It is not x squared minus 9. If you don't know how to square a binomial, you might want to just write it out as 2 of them. X minus 3, that's what it is, right? There's 2 of them. And then FOIL it, distributive property, to see what that equals. So don't make that mistake. Over here, you're probably going to want to move one of them over to the other side, something like this, before you square both sides, because if you were to square both sides with what you have right now, you would have a total mess. Okay? What do I mean by that? If I had the original equation and I tried to square both sides, yeah, I'd be fine over here. This is nice and easy. But on this left-hand side, again, this is not going to be x plus 5 minus x minus 3. There's a middle term there, right? And it would actually be x plus 5 minus 2 root x plus 5 root x minus 3 minus x minus 3. And I've now made it more complicated than what it was when I first started. Okay? So I would not want to do that. I'd want to move that radical over to the other side. And then I would want to try squaring both sides. And you might find out that you're going to have to do this twice. And I know I'm going fast through these. I just want to give you some things to think about. And maybe some of you are already done with these. Let's look at 5a and 5b. This time I have x to a rational exponent. I need to get rid of it. So like that 3/2, I don't want him there. I want x to the first. We talked about this when I had the PowerPoint up on Friday as well, right? So if I just clean this up, move the 25 over to the other side, I can divide by 5. That'll help me. So I get down to this. X to the 3/2 equals 5. Suggestion there? Kinda. We're not multiplying both sides. We're going to raise both sides to a exponential power. Right? And in so doing, we're going to multiply exponents times exponents. So I need to raise this guy to some power, some exponent. And whatever that question mark is, I got to do the same thing to the other side as well. So what's that exponent going to be? 2 over 3, exactly. Because it's his reciprocal. Because then if I raise this to 2 over 3, the whole thing's going to cancel and I'm going to have x to the 1. And I'll be good to go. So 5b is no different. The only difference is, take a look at, in this guy here, my exponent was 3/2. And in this guy here, my exponent is 2/3. Well, there's a key difference here. Okay? Whenever you have something to the 3/2 power, so let's say it's x to the 3/2 power, what that is saying is, that's the same as saying x cubed to the 1/2 power. Same exact thing. If I want to just break it into 2 chunks. And if I went over here and said x to the 2/3, that's the same as saying x squared to the 1/3 power. The other way I could say that is I could say x to the 1/3 squared. All of these are the same thing. Over here, I could say x to the 1/2 cubed. All of those, well, not all of them, but all of these 3 things are the same thing. All of these 3 things are the same thing. You just need to be clever with your properties of exponents. Now I know we learned all this stuff in 9th grade, but you tend to forget these things, right? So it's good to review. It's good to go back, look at your textbook examples, stuff like that. That's why we're doing this. I want you to imagine, this number right here. Pretend for a second that it is a negative number. A negative number. If you take a negative number and you cube it, what happens? Is it negative or positive? It's still negative. And then you end up trying to take the square root of a negative, because 1/2 power is the same as square root. Not going to work, right? So what do you know is going on here? You're not going to be able to get a negative answer. Do you see how that works? You can't take a negative number, cube it, still have it negative, and then take it to the 1/2 power. Taking it to the 1/2 power is the same as taking the square root. So you know that your answer for this guy is going to be a positive number, right? But now jump over to this one. What happens if this guy right here was a negative number. If you take a negative number and you square it, now you are positive. And if I take the cube root of a positive, can I do that? Sure I can. What happens if it was a positive number? Same thing. So, how many answers do you think we're going to get for 5b? 2. There's going to be a plus answer and a minus answer. But over here in 5a, how many answers are we going to get? Just 1. You see the difference? It's all because of this numerator. This guy has a numerator of 3, and this guy over here has a numerator of 2. If I have a numerator of 2, I'm going to get 2 answers. If I have any even numerator, 2, 4, 6, 8, 10, 12, I'm going to get 2 answers. If I have any odd numerator, I'm only going to get 1 answer. Again, that takes practice. That takes time. That's why I give you practice homework so you can practice those and you can start to see those patterns developing. Really quick, number 6 and 7. What do you think? Are they factorable? Say it again.
Move the 6 over?
Yeah, we could move the 6 over. We could try to complete the square. There's a lot of things that we could do here. There's more than one way to solve these. The way I see these, and the way your textbook, again, these are contrived. Okay, they were set up so that you could kind of see some things. This is what they call, they're not quadratic equations, but they are quadratic in form. They look like they could be a quadratic equation. For example, this is x squared squared minus 5x squared plus 6 equals 0. You see how it's kind of like a squared plus b squared, ax squared plus bx plus c? So one trick here, and you might have learned how to use substitution when you were in previous algebra classes. One trick here is to say, you know what? I'll use the letter u. If u was the same as x squared, then this equation would be u squared minus 5u plus 6 equals 0, and that is an easy equation to solve. That's an easy quadratic. And we have all kinds of ways of solving quadratics, right? We can factor them, we can complete the square, we can use a quadratic formula, but you should recognize that this guy is going to factor nicely, right? So I could solve this guy, and when I'm all done, I'm going to have 2 answers, right? U equals something, and u equals something. 2 answers, right? But I'm not interested in solving for u, I'm interested in solving for x. So once I have these 2 answers, I'd have to say, well, if u equals whatever this number is, then that number must be equal to x squared. So x squared would equal that, and then I'd have to solve that equation. See how I'm breaking it into an easier one for the meantime and then moving it back? So how many total answers am I going to get here? 4. Yep. Here's another one. You could say, boy, it sure looks like, if u was x to the 1/3 power, well, then I would have 3u squared minus 11u minus 4 equals 0. That is an equation that you should be able to solve. Whether you factor it or you use the quadratic formula or whatever you decide to use, you are going to solve for u, and then you're going to have to take those u's and solve for x. A little back substitution. I know I'm moving fast. I'm going to give you time. Some of you guys might have already done all these. Last 2. We haven't done any of these yet. Absolute value equations, right? I said in the PowerPoint that I gave you on Friday, what does absolute value mean? I'm going to write it out here. Absolute value. Correct. It is the distance from 0 on a number line. The distance away from 0 on a number line. So, what this is saying is the absolute value of 2x minus 1 is 5 units away from 0 on a number line. So imagine a number line with the number 0. There are only 2 places on a number line that are exactly 5 units away from 0. What are they? 5 and negative 5. Do you guys agree with that? 5 is a distance of 5 away from 0, but so is negative 5. So what it's saying is the distance from 0 is 5. So this 2x minus 1, he must live at one of those two places. He either lives right there or he lives right there, because those are the only two places that are 5 units away from 0 on a number line, right? So you're actually going to have two different equations here, yes? And you're going to have two different answers. And number 9 is very similar. Distance away from 0. Okay, I've been doing a lot of talking. I want you to try to start to solve whichever ones that you haven't solved yet, if you're already done. Or if you're done with some of them, I want to show you something. It's on Blackboard. Now, I'm not having you hand this in. This is purely for your practice. So if you go to course docs and links, and you scroll down to 2.6, here are the checkpoints that I gave you, the ones to work on, and there's a document there called Checkpoint Solutions. Now, if you're going to just open it up and copy down the solutions off there onto your paper, that's your call. But again, I'm not even going to ask you to hand this in. So I want you to actually try to work through them on your own. And when you get very stuck, ask a question. If you think you got an answer, go ahead and pull it up and look it up. Oren has a copy of the answer key as well. He's going to walk around and help you out. So I want you to work on these. Show me what you got for solutions. And then if you also have questions on your 2.5 Excel spreadsheet, we will field some questions on that as well. Okay, get to work.
So I feel pretty confident with my spreadsheet.
Yep.
I just had one question.
Okay.
In regards to so I'm pretty sure I know this one's right. But my thing is that, say if I had x squared plus 4x plus 5, it's going to be a imaginary number.
Correct.
So my thing is that's correct because it's not going to populate correctly.
Correct. And I suppose you could go through and make that not display if you wanted to, but don't worry about that.
So my question is, when it is
a real number?
When it is a real number.
Yep. So put like minus 5 in there.
Mine still populates down here.
And that's okay. So the discriminant is positive, right?
Mm-hmm.
So that is probably correct.
Still gives me the right answer, but not.
Yeah, this is wrong. So the reason this is wrong is, let me see what you're doing here. It's that's going to be that. Yep. So what you've got here, okay. The reason that is because you're not going to take the square root. Let me think here. The way I built this template is what you're doing right now is you're taking negative 2 plus 3, which is 1, mm-hmm. and negative 2 minus 3, which is negative 5. The way I built this template is I built it so that it would only do this. You used absolute value, and I used times negative 1.
Okay.
So when I use times negative 1, if this ended up being a negative, it would take it times a negative to turn it into a positive, which is why this would work for me. You're doing absolute value, so whether it's positive or negative, it's going to spit out an answer. Don't worry about it. Don't worry about it. You're fine. Do you see the difference?
Yeah.
So what I'm saying is, if mine is negative,
okay.
I'm going to take it. If mine's negative, it's going to produce a bad answer there, just like yours is. Right. If that's a negative number. Mm-hmm. So go ahead and change it back to positive 5. Okay. Negative number doesn't work. So what I did here.
This is the correct imaginary.
Yeah. You took the absolute, it's a negative number, so you're taking the absolute value of that, What I did is I knew it was a negative number, so I took it times -1, which is the same as if you take a negative times -1, that's exactly the same as taking the absolute value. See what I did? But if you take a positive times a -1, that changes it to a negative, whereas yours is staying positive. That's the difference.
So would I put my times -1 there or there?
It doesn't matter, because it's commutative. You can take it times -1 anywhere that you want.
Okay.
If you took out ABS and put times -1, I think yours would be the same as mine. But don't worry about that. Yours is good. Yep.
That was the one time.
No, definitely not. And that's a key error that a lot of students would make. What I would do is I would isolate that absolute value. So I'd move the 20 and I'd move the 4. And then if I can get the absolute value all by himself, then you should be able to do it just like you did number 8. Yep. It's definitely not distribution. Don't let your brain think that absolute value is the same as a parentheses, because they're two completely different things. So you're wondering if that's correct?
Yeah.
One way you could figure out if it's correct is you could work it out on paper.
Yeah.
You work it out on paper and see if that's what you got, but I can check it for you. 2, -3, and -1. So 2, -3, and -1. Give me a second.
Not even close. What did you do?
So.
I have -4 and 12. Is there anything we can check against?
Yeah, in fact, I got mine on the screen. Is that what yours says? So which numbers are different? Because 2, -3, and -1 is what I entered. So good.
It's just me trying to type it in.
So you have your discriminant is wrong. Your B11. So what you probably did is you square root B squared minus 4 times A times. That should work. Square root G8. What's G8?
Don't square root it right away.
Okay, let me see how you fix that. Oh yeah, the discriminant doesn't have the square root. It's only the part under the square root. Yes, now you're right. Now your only mistake has got to be right down in here somewhere.
But
okay, I can already tell you where it's going to be. Look at the very end.
Very end.
What you've got is you've got a whole big whatever divided by 2 and then times H9. You've got this divided by 2 times A. The A needs to go in the bottom. You just need another set of parentheses, right?
Oh, do I make
Did it work?
this? Or do
Correct.
Then it gives me.
Something else might be wrong. Okay, think about, you want the whole darn thing. That negative B also has to be divided by, so you need a parentheses around the whole darn thing. You want the whole thing. Negative B plus or minus square root of.
Oh, that entire thing?
You want that entire thing over 2A. Right now it looks like you have it like right there or something.
Yeah, I got it.
You want this whole thing, right, divided by 2A.
Got it.
So it's just an order of operations issue that you have going on. Otherwise, you're spot on.
I'm still not getting those classes.
Let me see. So -3, 2 negative. Okay, so C. Okay, you did the same thing. That Alex just did. Take a look at what you've got going on here. is you're taking this whole entire thing, you're dividing it by 2, and then you're taking it times B6. You don't want to do that. You're doing this. You're dividing it by 2, and then your A is up top. That A needs to be with the 2. Order of operations. That's a common error.
Okay, I got it.
Did it work now?
I got it.
There. So how you doing on the second one now?
I was focused more on that.
Yep. No. Hey, no problem. So now here's what you know. If you know now that your first one works,
Well, I got everything minus.
whatever you enter in the second one, you're going to get the same final answer. It's just a different process. So you can always check to see if this one works by going to your other one and checking to see if it works.
Okay.
Get the right answer.
So you have, okay, so now look at your order of operations. All you're doing, your 2a at the end,
Yeah.
all you're dividing that by is the b squared minus 4ac. You need to start a parentheses at the very beginning and at the very end, and then divide it by 2a. So again, it's an order of operations issue that you have going on there.
We don't have any. Oh, no.
I know that. So I can, let me just punch in a different one here, Katie. I'm just going to make up some random numbers. How about -3, 4, and 17?
See, my number.
Try that. See if you get the same thing I get. Okay. Yep.
Now that I got the discriminant right. Yeah, because these two should want to change this number. And that number right.
So how do you find this?
So you've got everything entered, right?
Yep.
So if you were doing it on paper, it'd be, you'd just do some arithmetic, right?
Yep.
-4 plus or minus the square root of 16 minus 4 times 1 times 4, and you would just work it out arithmetic, right? So what you want is you need to type in a formula, and it's probably going to be kind of long and ugly. You're going to have to type in a formula into C13 and C14 so that it spits it out. You want it to do the arithmetic for you. And where some of the students are going wrong is they're getting parentheses in the wrong place, and their order of operations gets off. So that's why I put an example on the board that if you just type in what I have up there, like I have -3, 4, and 17, you should get -1.8 and 3.13.
Okay.
Yep.
So yeah, so for their part, right, when they get through this step right here, for this step right here, should this number right there be this one divided by 2 squared?
Correct.
Okay.
Yep. So right now,
on the other side.
right now you have a -3 there, right? And that -3 came from the original equation, right? Just humor me for a second. Instead of 1, put like a 2 there. I want to see what you did. 2. Okay. So you're not quite there yet. Because you're line 8. Before we even get down to line 10, you need to take care of line 8. And line 8 says make that a 1. So how are you going to make it from a 2 into a 1? Yep. Divided by slash. Divided by. Nope, because it's not always going to be a 2. But it is always going to be in cell B6, right?
So it's a B6?
Yep. There. So now go over to your next one, E8. You don't want it to be -3. You want it to be whatever is in E6 divided by what?
Because you didn't save it.
You're gonna divide that guy and that guy and that guy all by B6. Yep. Very good.
Save it and then rename it.
So there's always going to be, with this, putting times -1 works, by the way.
Oh yeah. Yep.
So I take square both sides.
Yep.
So then I have x plus 3 equals
Perfect.
this. So
Perfect.
now I factor this, which gives
Yeah.
me...
You actually multiplied it. It was factored and you multiplied it out.
Yeah.
Yep.
So then I have this, which gives me...
Perfect.
Then I add everything together. So then I move everything to one side. So then I can
Solve.
solve for the quadratic equation, which gives me these two answers.
Perfect. Yep. So now the question is, now that you know that the answers are 6 and 1, you got to ask yourself,
Can I plug it in?
plug it back into the very original equation, because it's possible that you created an extraneous solution. Remember we talked about that on Friday? So see if they both work. So if you plug in 6, you'd have 6 plus 3 is 9, square root of that is 3. Does 3 plus 3 equal 6? Yes. Try 1. 1 plus 3 is 4. Square root of that is 2. 2 plus 3 equals 1?
Use those numbers up there.
No. So what really is your answer? Just 6. Do you see how 1 doesn't work? Even though your solving method tells you that 1 is an answer, that's the extraneous solution. Your answer is 6 only.
Awesome.
Good.
Okay. We skipped this step.
Now everything looks good on line 8. Yep. So, that cell you're in now, it's just going to be a repeat of B8. You know what I mean? We're just showing our work again. I would just say equals B8. And same with that. That's just going to be a repeat of E8. Because we're not doing anything different yet. Now we are. Here's the completing the square step. But you can do it. You don't even have to do the arithmetic in your head. It's E10 is the one you're interested in, right? What are you going to do to E10? And then do what? Yeah, and do that all in one formula. Use your parentheses appropriately. How you guys doing over here?
We had all this figured out, but we have no clue where you're going with this.
Oh, so you're just working on the bonus.
Yeah, I don't know what to do.
Okay, you're telling me everything but the bonus is done?
I think so.
Okay, humor me. Type in what I have up there. -3.
It's on quadratic.
No, you leave it on either one. Type in -3. I just want to see if it works. And 4. And 17. Something. Okay, so it's not working. So I can tell you right away what should have happened here is, I'm not sure. Okay, before you can even get to line 10, seems to me that this, click on that cell for me, you took half of it and squared it, but you took half of that number, but we're not going to do half of 4. We're actually going to do half of -4/3, because before you can complete the square, this 3 has to be a 1. So that's
we
what.
just have it if this is
So-
always 1.
Exactly. So you skip line 8. So before you even get to line 10, on line 8, you need to find a way to change that -3 into a +1. So how would you do it on paper? Divide everything by -3. How would you do it on Excel? You're going to divide B6 by B6.
Oh, yeah.
And over here you're going to divide E6 by B6. And H6 by B6. You're dividing everything by there. Then you can get to line 10.
I feel it. Oh, never.
And then when you are on line 10, you're not going to do E6, you're going to do E8. You see how you're showing your work moving down?
We should really, on this one, just have to change our E6s to E8.
Yep,
And then everything should work.
Correct.
Like here we just have E6 in the wrong spot.
correct. Yeah, it's probably a quick fix. Flag me down when you think you got it. Are you raising your hand, Luke?
So, if I take this one and square both sides,
Good.
then I get x plus 5. Am I squaring this 2 or no?
Okay, here's where you're going wrong. Common mistake. This is actually what I just said is not the answer. So it's 2 plus root x minus 3. 2 plus root x minus 3 squared, right? Okay, this is what you have. It's not 4 plus x minus 3.
It's what I did here.
Correct.
Okay.
So if you're fast at this, it's actually square plus twice the product plus square. If you're not fast at it, just write it out and FOIL it.
E6 divided by
First, right? First, outside, inside, last. I don't know if you've heard of FOIL before. That's the distributive property. That's what you did right here. You take x times x and you got x squared. Then you did the outside, which was negative 3x, the inside, which was negative 3x, and the last, which was 9. Same process.
But where does the square go? This is square.
Okay, so 2 and 2 is 4. 2 and root x minus 3 is that, right? 2 and root x minus 3 is that. And root x minus 3 and root x minus 3 is x minus 3, right? So now what I've got is I've got a 4 and a negative 3, which is 1, and an x, and I've got 4 of these. 2 of them and 2 of them is 4 of them. And now I got to move all the stuff and I got to do it again. See how I had 2, right, and got rid. Now I got to get rid of the other one. So you're going to end up squaring both sides of the equation twice in that guy because your original equation had 2 of them and you can't do them all at the same time. Does that make sense? How we doing?
So, the way I think this is supposed to go.
Okay, it's not B6 divided by 2, right? It's B6 divided by B6, because if I change that to a 7, then you're going to want a 7 there, right? So it's B6 divided by B6. And this is going to be E6, not divided by 2, but divided by B6. Don't type in a 2 because that number's not always going to be a 2. So type in B6, and whatever you put in B6, it'll always go with you. Does that make sense? Basically, you never type in a specific number into any formula. You're always typing in cell references, because you got to make sure that if you change those yellow numbers, the whole thing changes with it.
So then
I'll come back.
So should this be negative 2 then instead of?
So your H10 is your blank, your new number, and it looks like it's correct. And then that negative 2, you actually moved it, you added it to both sides, and that's why that's a 2. So what this should be then is negative 8. Perfect. So, let me see if you did this correctly. Perfect. Now you're ready. So this next one, this J12, that's just going to be the sum of those 2 blue ones together, right? Think about doing it on paper. Isn't that what you would do, is just add those 2 together? J10 and L10? Yep, perfect. And now, if you were to factor that left-hand side, what's going to go in there? You're right on pace here. For the discriminant one? Remember, the discriminant is only the part that's under the square root sign.
So I don't have to put the square root.
Correct. The discriminant is this, b squared minus 4ac. That's it.
How do I do the squared part in?
Do a caret 2. It's the
Would
shift.
it be inside the parentheses or outside?
I don't think it matters in that situation, but it would be, there you go.
That? Oh, okay.
Perfect. Let me see it again. Go click on it. B squared minus 4 times A times C. Perfect. Yep.
When I solve it, do I just have to type in everything like I would?
Yeah, depending on how you want to do it. I mean, you can utilize your B11 since it's that part, or you could just use that for display and try to put the whole darn formula into one cell. Yeah, and when you put the whole formula into these 2 cells that you have left, it's going to get long and ugly. So you really got to make sure you got your parentheses in the right spot so that your order of operations is correct.
Okay, thank
Yep.
you.
Yeah, but I'm using it. So I typed them in, but they're the same answer.
So let me see. Remember, it's plus or minus. So it looks like in this cell, you're doing negative b plus the square root, negative b minus the square. So it should have worked. Now, the only thing you got going on here, you've got order of operations problems here. Because what you want this, first of all, it's not D8, it's negative D8. right? Negative
Oh,
b.
gotcha.
So you want negative.
Oh, then that makes
Okay. But you want all this. Here's what you have right now. You have negative b minus the square root of b squared minus 4a. Oh, you don't even have that. You have the square root of b, and then you want the square root sqrt of all of that garbage. So you gotta open your square root parentheses. B squared minus 4ac, close parentheses.
Okay, gotcha.
Your order of operations are all off.
Okay.
So see if you can fix your parentheses.
What's this mean?
Basically, what it means is you're taking the square root of a negative number. So you're having the same problem here. You've got negative b plus the square root of b squared minus 4 times a times c divided by. You want that whole thing. You'd want equal, huge parentheses, all this stuff. Close parentheses, divided by big parentheses. You need all of this right here. You need all of this in the numerator, negative b plus or minus the square root of b squared minus 4ac. You need all of that somehow in 1, because that's my entire numerator. Divided by, and then you need all of this 2 times whatever your a value is, all in 1 parentheses. What you have right now is you have negative b plus the square root of b squared minus 4. You see that your parentheses are all off. So try to do 1 parentheses, an open parentheses that goes for your entire numerator, and a closed parentheses at the end of your numerator, and then you're going to have a bunch of parentheses in between. Yeah. Yep.
So does this make sense?
Mm-hmm.
Okay.
So type in what I have up there, negative 3, 4, and 17. And then you can check to see if it works.
Okay.
Negative 3, 4, and 17. Okay, so something's wrong. Your discriminant's correct. You still have order of operation issues going on here. Negative b plus the square root of b squared. Okay. No, put your entire numerator. So right beside the equals, put an open parentheses. Right beside the equals.
Okay.
Open it, and then close it after.
This one?
Yes.
Okay, so
Try
I have
that.
to get rid of this, right?
You can. It's probably okay if it's in there.
Okay.
And then your square root. All your square rooting right now is g8. You got a square root g8 squared minus 4 times a times c. So you need another set of parentheses there. Right?
Yeah.
No.
Okay. We are just about out of time. I can tell on this spreadsheet that some of you have gone from I have no idea what I'm doing to now I think I have some idea of what I'm doing. Okay? And that's what I hoped that you would get out of this. Okay? I know some of you haven't quite mastered it yet, but you've come a long way in the last half hour. So hopefully you can hit the ground running. Remember now, it's due on Wednesday. Even if you're not 100% sure that it's correct. First of all, I'd want you to be pretty darn confident that you know that you're submitting something good. But even if you submit something with a mistake on it, we'll look through it. We'll see if we can find your mistake. We'll send it back to you and say, you got a couple things to fix. Okay? So make sure you have it in your shared folder by class time on Wednesday. The equations that you've been working on from 2.6, I already showed you where to find the solutions. So practice them. It just takes a lot of practice. So do your practice homework from 2.6. And we'll do 2.7 on Wednesday. So
And then quiz for 2.6.
yeah, you can take the quiz for 2.6. Remember, all of your quizzes are due before you show up on Friday, right? 2.5, 2.6, 2.7, all of them. Okay, see you on Wednesday.
English, then I got lifting.